In this video, I introduce a Wave2vec self-supervised pre-training for speech recognition. Self-supervised learning doesn't predict the future observations xt plus k directly from x1 to xt with a generative model pk. Instead, it models the density ratio to maximize the mutual information between x and c, as shown here. This context C and this input X, which defines information noise contrastive estimation loss, as shown here. Where FT is used to estimate the density ratio. A set of samples from X1 to Xn includes one positive sample from P and N-1 negative samples from P. Self-supervised learning uses the contextualized CT and the encoded ZT plus K to build a log bilinear model, as shown here, which is used for self-supervised learning and preserving mutual information between X and C. Wave2vec is a self-supervised pre-training model for speech recognition by learning repetitions of raw audio, which is trained on large amounts of unlabeled radio data and the learned repetitions applied to improve the acoustic model training. Pre-training from audio data X is encoded with two convolutional neural networks, Z and C, as shown here, this is Z and C. That are stacked on the top of each other. The model is optimized to predict a next representation. Given an audio signal as input, the regular training models predict the future sample distribution Px from a given signal context, which is difficult. However, Wave2vec further encodes the raw speech samples X into a feature representation Z at a low temporal frequency, and then models the density ratio P by P here. That is used to learn representation of input signals. Wave2vec distinguishes a sample Z I plus K that is the key steps in the future from distract samples Z-tilde, drawing from a distribution Pn by minimizing the information noise contrastive estimation loss Lk for each step K, as shown here. Where sigma is the probability of Z I plus K being the true sample. If find transformation Hk is equal to Wk times Ci plus bias Bk is used for each step K. The final loss over all K steps is defined as here. This is the input signal, this encoder, and this contact network. At each step, we pre-train to learn representation Zk. After Wave2vec is trained, then contextualized Ci is used as input to acoustic model, as shown here. For more details, please check with these references. Thank you.